Hi, welcome to this next video on division and remainder. This would be the sixth video on this. My name is Prashant Mohan Thakur and I welcome you all on Competition Valley. So we left in our last class for this question. So we'll just solve it and just you can match it down if the answers are correct or not. So it was 25 by 7 and we needed to find the remainder. So what we can do is, again, Euler of 7 is a prime number, so it would be 6. So we can do 6, we can write this as 25 by 7, and then we can write as 62 by 6, which will be 2. And then we will have 7, 3, 4. So we will have 4 as the remainder over here. So it will be 16 by 7. Again, remainder cannot be more than the divisor. So our remainder would be 2. Okay, so those of you who have stopped over here, if you have stopped over here, then that's going to be a blunder, because remainder can never be larger than the divisor. So that's why we have to divide it again. So now we have 2:7, so our remainder is 2. Okay. We'll do the next one now, 97. So again, 97 to the power 91 and remainder, so 10. Again, if you 2 and 5, so how can we write it? 1 is to 5 into 4, so you have 4. So Euler of 10 is 4, so we can write 97 by 10, and then we can write 91 by 4. So it should be around okay, so it should be 97 by 10, we get 7, and then we have 94, so it should be 22 into 4 is 20. 22 into 4 is 88, so it should be 3. So the remainder should be, and then 7 by 10 is something, so it can be 7 into 7 into 7 by 10. So again, if you check the remainder, it would be 10 in, so okay, so it should be 343 by 10, isn't it? By 10, so the remainder should be 3, I guess. Yes, that's what it over here as well. So it will be 3. Yeah. And the last one, is 188. over here is 188 by 101. We need to find the remainder. So 101 is prime. Let me see. E 101 equal to 100. So what we can do simply, 188 by 101, and it would be 100 by 100, so it will be 0. So 0 on top of everything is would be 1, so the remainder would be 1. So if you thought it, if this goes 0, don't convert everything into 0, because anything to the power 0 is 1. Okay, so don't just stop over here, so the remainder will be here. So I hope you are quite clear with Euler number, and also you're quite clear with how the concept of Euler number can be used to find the remainder. Okay, so now let's look at this question. Okay, so it should be 50 by 53. Again, find the remainder. Or what we can make is over here is, okay, so it's simple. 53, it's a prime number, so what we can do, 50 by 53, and then 53 by 52. So what do we get? 53 by 52, we get 1 as the remainder, and 50 by 53. So either you can take 50 or you can take 50, there's no problem with that one. So you have 50 as a remainder, isn't it? Now if the same thing, we go one more step back, 50 by 53, and we take 52 over here as a remainder, then what we do? Then again 53 is a prime number, so 50 by 53, we have 52 by 52 r, so 52 by 52 is, remainder is 0, so on top of 0, so it would be 1, isn't it? Now if we have this question, if the question is 50 by 53 to the power, let's say 51, find the remainder. Okay, let's do this in next slide. Find remainder, it 50 by 53 to the power 51. Okay, again 53 is a prime number, so very simple, 50 by 53, 51 by 52, that's how it should be. But now we are in a fix over here, because this is not coming in a format of whole number, because over here if you see, this 51 is in itself less than the divisor, isn't it? What makes then 51 is the remainder, ultimate remainder, so it should be 50 by 53, because 51 is the remainder over here. Now understand what I'm trying to tell you here. What we did in last video is 50, 52, 53. If this would have been the case and we would have been told to find the remainder, we could have done 50 by 53 and 52 by 52, because this is a prime number. Okay, so this is a solution. Even if we have been told to find for 53, still we can do that, considering that 50 by 53 and 53 by 52. Look over here, because we have remainder, see over here. Okay, so we can still divide it, because the remainder, if you see over here, is larger than the divisor. It means we have an option to divide it and take it to the simplest form. Over here also it's divisible, but over here it's not. So how do we go about doing such questions? Okay, see again. So if we write this part 50, so let's try to solve this. Okay, so again we'll go reverse direction. Okay, instead of going forward this way, we'll go this way. Okay, how? I'll tell you. 50, let's say 50, 52, 50 to the power 52 by 53. If this would have been the case, what would have happened? It would have happened 50 by 53, 52 by 52, and we would have got 1, isn't it? That's how it would have been done. So can we write now? So therefore, can we write this term over here? Can we write this term as 50 by 53 to the power 51 into 50? Look carefully. This is what over here, 50 has 52 power. Over here is the same thing. Now can we find remainder from here? Can we go from here itself? So, and now again, see over here, we are looking, we are breaking this expression into this one. Now this term 50 is getting divided by 53. So let's look at it in simple form. Let's say we have 57 by 8. Okay, so can we say that this particular thing is in a format of 8k plus 1, isn't it? Because 8 will be dividing this number with something. So let's assume that something is k and remainder is 1 because we have derived the remainder. Again, can we say 100 by 9, it should be in form of 10k plus remainder, isn't it? So can we write this term in form of 53k plus 1 because we have already seen that the remainder of 53 is this one. Now we are breaking this term into this, so it would be, so this term would be equal to 53k plus 1. Now look over here again, 50 to the power 52 by 53. What we have done, we have splitted it 50 to the power 51 into 50, so this remains the same. This we have just splitted it so that it's more visible, but it's exactly the same. It's just a replica of that. Now this number is equal to this because we have converted it to the form of division into quotient plus remainder. That's what we have done over here, and remainder we have already seen is 1. Okay, so now from going from here, what we can do, 50 to the power 51 by 50 into 50 by 53 is equal to 53k plus 1. Seems good, nothing problem with this. Now we'll try to find the remainder. So over here the remainder would be 3. Actually it would be minus 3, but again, since the remainder cannot be minus 3, if you want you can take the connotation as minus 3, but again it has to be all in real terms. So we can take 51 by 53 into 3 is equal to 53k plus 1. So this goes 50 to the power 51 by 52 is equal to 53k plus 1 by 3. Now this is what we have now. So for what value of k would this equation can be solved? So if we take k equal to 1, we have 54, so we have 18, which means that this is equal to 18. The remainder would be 18. See what we have done? We have, instead of going forward, we went in the reverse direction. Okay, we went reverse, and then from there we started simplifying the things and doing the things easier. Okay, we'll be doing a couple of more questions so that it's easier for you to understand it. Okay, so let's do another question over here. It's 70 to the power 73, and what we can do here is we can take 71. Let's see if this works out. Okay, again in the general case, what we would have done, in the general case we would have done 70 by 73, and then we would have done 71 by 72 because 73 is a prime. For any Euler that is prime, it is p minus 1. But again we have a problem over here. Remainder is smaller than the divisor, so we cannot move from here, so we'll go in the reverse direction. So what we are going to do, we are going to look for a different number. 70, this is what we're going to look for now. So 70 to the power 73, and then 72 to the power 72, so we would have 1. I'll just write it. So it's 70 to the power 70, 71, or can be written as 70, 72 by, okay, we are trying to find, we are going this direction. Okay, so now we are trying to find this one. So what happens, this is 70 by 73, 72 by 72. Now over here the remainder is 0, so 0 on top of anything gives us 1. Okay, therefore we can also write that 70, this in form of 73k plus 1. 73 because it is dividing, and this is a divisor, this is a quotient, and this is the remainder. That's what it is. Dividend equal to divisor into quotient plus remainder. So that's what I've done. So now we'll start from here. So we have 70 by 73, 72. So if we break it, what we're going to get, 70 by 73, 71 into 70. That's what we're going to get. So far everything is good. Equal to 73k plus 1. Okay, so 70, 71 by 7. Now again, this part we are going to take the remainder. So it would be 70, it will be 3 equal to 73k plus 1. It implies 70, 71 by 73 equal to 73k plus 1 by 3. So for what value of k would this equation would be fully solved? So we can check with 1, so it will be 74. For 2 we can check 47. For 3 we can check 220, which is not going to be happening. So for 4, no, for 5 looks it can happen. So for k equal to 5, if we take k equal to 5, so we have 3 equal to, if k equal to 5, so we have 366. So we have 1, 2, 2. K equal to 5 is 122, but this cannot be the remainder because it's more than 73. So there's some problem over here, which means there's some numbers before k equal to 5 that can be used over here. So we can check for 3. Again, 73 into 4 was 293. No, this cannot be done by 3. Then for 2, if we check for 73 into 2, okay, this is what for k equal to 2. Then it means for k equal to 2, if we go from here, for k equal to 2 we are getting 147 by 3, which is 49. So the remainder would be 49 over here. Okay, always remember, remainder can never be larger than the divisor, and that's how we got to know that if we use k equal to 5, we are getting r equal to 122, which is not going to help us. Okay. So let's do one more question. So find 29 by, we can take 31 and we can take over here 29. Find r. Okay, so we know how to start. So simply we'll have to go to the reverse direction. So we need to check for 29. We need to check for 30 by 31. This is what we need to check for. 31 is a prime number, so we know all Euler prime number is p minus 1. So it should be 29, 30 by 30 by 31. So we are getting 1 as a remainder because this is gets 0. So anything on top of 0 is 1. So we're getting 1 as remainder. Okay. So what means is, it implies that we can write 29, 30. This can be written in form of 29 to the power 29 by 31 into 29. We can write this way. Now we are breaking this term, so this term can be written as in form of 31k plus 1. K, 1 is the remainder, k is the quotient, 31 is the divisor. So it should not be difficult from here now. So 29 by 31. Now I'm just writing in simple step so that each one of you can understand. And 29 by 31, the remainder is 2. Okay, 29 by 31, the remainder is 2, so 31k plus 1 by 2. So for what value of k, now this would be solved. So we can look for k equal to 1, we have 32, k equal to 1, we have 31 plus 1 by 2, which is 32 by 2 for 16. So 16 would be the remainder. So it's very easy, you know, it's very, very easy once you find it. Now, because we are using a reverse method over here, so this process, what we are doing right now, this process is called reverse Euler, because we are using Euler, but exactly we are using Euler in a reverse direction. So also this process is called reverse Euler. Okay, it's just a part out of Euler, but in Euler what we do, let's say in Euler we take the Euler out and then we start doing. Over here we go a step back and we try to see for the factors for the number and for the power, and then we go ahead and do whatever is necessary. So this is reverse Euler. Okay, so if someone says a term like reverse Euler, do not think that you have not been taught about that. Okay, so we'll do one more question. So let's do this. We can do 99 by 101 upon, we can do 599. Let's do for this. Okay, so again we're going reverse. So 99 to 101, we are checking right now for 600. Okay, so for 600 what we have to do, 99 by 101, 101 is a prime number, so what we have to do, 600 by 100, again remainder is 0, so we are going to get 1. So now what we can do, we can write 99 to the power 600 by 101 can be written as 99 to the power 599 into 99 by 101, which means equal to, equal to 101 k plus 1, because 101 into something plus 1, remainder is this value. So yeah, so what we're going to do now, 99 to the power 599 by 101 equal to 101k plus 1 by, now remainder over here would be 2, isn't it? Yeah, so 2. For what value of k would be this equation can be satisfied, this part fraction can be satisfied. So if we take k equal to 1, we have 102 by 2 equal to 51. So the remainder over here would be 51. So that's how it is. It's very easy, provided you understand the concept. Okay, so we'll do one more question. So find R 1300 plus 1700 by 25. We need to find R. Okay, see there are several methods to do these questions. One of these methods over here, you can use binomial expression as well. Of course I have not taught binomial expression, and of course I would not be teaching this, because this is, even if you do with all the perfection, it will take at least 4 minutes for sure. You know, you can, this is a question from CAT, this has been asked in CAT, and you can't afford to lose 4 minutes on a question. You can see most of the websites or most of the places this question would be done in binomial expression, but if you choose to do that, you would be losing a lot. Okay, so we'll be using the same concept what we have been studying to do such questions. So what we can do over here is, now can we break this part over here .25. There's no harm, because even if you combine it, it's still going to be the same. So now we have to find we can find the remainders individually. So we know how to do that. Again, first of all, Euler 25 is, we know 25 into 4 by 5, it would be, should be 20, because 5 is the only prime factor. 5 into 5 is a perfect square, so 20. So what we can do is 13 by 25 and 100 by 20. Over here 17 by 25 and 100 by 20. So what we see over here, this part goes 0, this part goes 0. So anything anything with power 0 is 1, and over here is 1. In between you have a sign of plus 1, it's 2. We can do it less than 3 seconds. Simple. See, nothing. I've just split it. Even if you would have not done, you could have done straight away as well, but I've just done it for your convenience. If you practice it, you can just look at the question, look at the answer, and you can do it in one shot. Okay, we'll do one more question. What is the remainder in 382 plus 582 by 34? Okay, so let's do again simple. There are two ways we can do it. 382 by 34 and 5 to the power 82 by 34. So very simple. 34, what would be the Euler of 34? It will be 34 into 1 by 2 into 16 by 17, isn't it? See, the denominator should, once it multiplies, it should be equal to 34. Okay, so 34 goes, so we have 16. So what we can do, 3 by 34, 82 by 16, and 5 by 34, 82 by 16. So what do we have over here? 3 by 34 and 16 into 5 is 82. So what is the left behind remainder is 3 to the power, and over here 5 to the power 34. So 9 by 34 is 9 remainder, and 25 by 34 again is 9 remainder. This 25 by 34 and 9 by 34. So if you want, I can again split over here. It comes because 9 by 34, 9 is the remainder. If you see over here, I'm sorry, it's 25 by 34, so 9 is the remainder, and it comes 9 by 34, so this is the remainder. So we have 9 as a remainder and 9 is a remainder, so 9 plus 9 is 18 is the remainder. Okay, so very standard question, very good concept. Okay, so we'll do one more question, and that should be probably the last question. So there would be ample questions done, so that even if you just watch this video and watch this again and again, you will not feel isolated while you are going in examination. This should be enough. And I will be doing, whenever I complete a topic, I do a video or a couple of videos, just questions and all those concepts that we have learned during these sessions. So do not worry about anything. Okay, now again, find remainder. We can say 3 plus 5 by 34. Okay, how would we go about doing this? Again, you may say 390 by 34. We can split it, and 590 by 34, isn't it? Again, Euler of 34, we will take 34 into 1 by 2 into 16 by 17. It should be 16. So 3 by 34, 90 by 16, 90 by 16. So we have 10, and now we can't go from here, isn't it? We have stuck over here. So how to proceed over here? So I'll tell you now. See, 3 to the power 90 can be written as 3 to the power, can be written as 3 to the power into 45. Similarly, 5 to the 90 can be written as 525. We have learned this, we have studied this in number system as well, isn't it? So I'll just delete this part. So can we say over here that, then can we write this entire thing over here is 3 to the power 45 plus 5 to the power 45 by 34. Now how does it help us? See, now and this is a very important concept as well, and that's why I took this question. AN plus BN is completely divisible by A plus B if N is odd. Remember, if N is even, then it's not going to help. If N is odd, it can simply be done anytime. Let's say you have 2 cube plus 3 cube. I'm sorry, 3 cube. So how much we have? 8 plus 27, 35. See, it will always be divisible by A plus B, 5. So that's what I am going to do. So what do we see over here? AN plus BN. So AN plus BN would always be divisible by A plus B. It means that this number would be completely divisible. So it would have remainder as 0. It would not have any remainder because it's going to be completely divided by A plus B. So it would have remainder equal to 0. Okay. So the concept over here is if AN plus BN. Okay. So the concept part over here is if AN plus BN, where N is odd, AN plus BN is divided by or divisible by A plus B. You can write divisible over here, divisible by A plus B. Okay, so that's what we used over here. What was the question? 390 plus 590 by 34. What we did? 345 plus 45 by 34. So now this would be entirely divisible, so we would have remainder equal to 0. Okay, so that's the concept. Okay, so we'll stop over here, and in next class we'll be doing some more questions, and if there is any more concept that is left behind, we'll try to do that. I don't think there's anything left behind, but still, if there would be anything left behind, I'll try to use that, and we'll continue this in our next class then. Okay, so thank you for visiting Competition Valley. My name is Prashant Thakur, and bye for now.